So, hello everyone, my name is Sandeep. I'm a developer advocate based in San Francisco. I have flown around the world and then flown back, and then I decided to stop in Ukraine. Great country so far. How's everyone's DevFest? Good? Yeah? Alright, awesome. Hopefully I won't ruin it for you. So today I want to talk about microservices with Kubernetes and Istio. So everyone knows, this is a fact, that microservices are awesome, right? Because you have all these different components of your app, user logic, business logic, a database. Putting them into their own separate service makes it a lot easier to manage and update each one independently. And then once your team starts growing, you can take each of these components, put them in their own microservice, and you can have small teams that, one team can own invoicing, one team can own the data warehouse, and then each team's independent and can scale. And it's really good because everyone gets lunch together and it's great stuff, right? And then you grow a little bit more, and then no one understands anything. And you're like, microservices are terrible. Why did those Google developer advocates ever tell me to use microservices? Those people are just terrible people. But the truth is we can use tools, right, to kind of make them awesome again. And if you have thousands of services, no human being could ever manage them themselves. So let's let computers do this boring stuff for us. So how many people here are familiar with Docker? Most people. Okay, I'm going to skip right through this. So yeah, you put your code in a container. Yay. Okay, so now running and managing applications, Kubernetes. How many people are familiar with Kubernetes? Everyone? Okay. So this is a beginner talk. Why are y'all here? So of course what Kubernetes does is it takes your container and it actually runs it on the cluster, right? And so you don't have to worry about where these containers are running. You don't have to worry about keeping them up. You don't have to worry about managing that infrastructure, right? Instead, you tell Kubernetes, I want 2 orange, 2 yellow, 2 green, 2 black, and it'll take care of running it for you. Okay, so here's the interesting thing, Istio. How many people are familiar with Istio? Much less. Okay, so this is what we're going to focus on for the majority of this talk then. So Istio is kind of a layer on top of Kubernetes that you really need to manage these services. So we have orchestration, right? And all these are running. But now we have to actually communicate between these services. And that's where it becomes really difficult and tricky, right? So we want to manage that communication and have a centralized policy and rules and things like that so this doesn't go out of control, right? Because no one can make sense of that giant picture. We need computers and systems to kind of automate this for us. Okay. So that's enough of me talking. This talk is literally 99% live demo, so let's just get right into it. So again, this was a beginner talk, so I'm going to go through everything just in case there's people in the audience who don't know what Docker and Kubernetes are. But I'll go through it relatively quickly. I'll have a lot of time for questions. So the first thing we're going to do is put an app in a container, run the container locally, push the container to the cloud, create a Kubernetes cluster, run our app on Kubernetes, scale our app, and then we're going to look at Istio. We're going to run multiple apps together, a true microservices, situation, and then monitor and manage them with Istio, which is going to be the focus of this talk. And don't worry, we're going to take it slowly because we have a lot of time. Okay, so here I have some code, and it's pretty straightforward. First of all, we have our license, very important. But what this code is, let's see if everyone can read it. Can everyone read that? Kind of, yeah, okay, cool. So it's a very simple Node.js code. Basically, it has a upstream URI, in this case, worldclockapi.com. I used to use JSON test, but then they keep getting 500s because they have no quota. So what it's going to do is it's going to ping this endpoint, get whatever it outputted, and then just basically output that, right? So it's going to take whatever the downstream service outputted, wrap it with some timestamps, and then output that. So the really nice thing about this is you can chain an infinite number of these together and then just keep wrapping the response and another response and another response. We'll take a look at what this actually looks like in a second. So it's really simple, right? It's listening on /. It's just an Express app. And then it just waits for that request. And then, like I said, it gets to the current time and then the end time and then just kind of pastes it all onto the screen. So enough talking. Let's actually just look at what this looks like. So I'm going to run it locally first. And this is Cloud Shell. It's a free Linux environment that any Google Cloud user can use, which is really nice. Okay, so you can see here I have my Docker file, index.js, and package.json. So all I'm going to do is run it locally, so just go npm start. Oh, well, first I got to npm install, of course. So we're going to install our dependencies. Should have done this before. All right, now npm start. Assuming I have no bugs. All right, perfect. So let's go and look at what this looks like. So I'm going to preview on port 3000. Okay, so what it's doing is it's printing out the name of the app, which is test1 version 1. It took 0.392 seconds to go talk to this endpoint, and this is what worldclock.com blah 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 gave out, right? So it gives the current time. And if I go to this website, you can see that, that's what I get directly to. Cool. So basically, we're just taking this response and then wrapping it in some other stuff. Nothing really interesting, but it's a very simple app that we can see work, right? So the first step is taking and putting that into a Docker file. So how many people were at the previous talk? Few people. Okay. So we showed off basically a Docker file there. I think most people in this audience know what this is. Using Node 8 Alpine, copying in the package.json, running npm install, copying index.js, exposing port 3000, yada yada, right? So this is basically taking the code and then putting it into a container. So let's just run that. So I've already built it and pushed it, so this is like opposite of what I told you we were going to do, but that's okay. So we're going to run it, and it looks exactly the same. And if I go back on this thing, it looks exactly the same. There's no difference in terms of what I see as an end user. It's just now wrapped in a container, right? So the really nice thing about this is you can take any code you want, right? Any language, any runtime, any dependencies, put them in a container, and this container is portable. So you can take this container and run it on your local laptop. You can run it in the cloud. You can run it across multiple clouds. As long as it can run a container, it can run your code, right? Okay, so that's all well and good. But how do we actually run this on Kubernetes, right? So our next step was basically to store the container securely in the cloud. So for this, we're going to use Google Container Registry, but you can use Docker Hub, you can use Quay, you can use any container registry that you want. So what we're going to do here, I'm just going to run this command, and what it's going to do is run docker push, and then the container name, right? And it already exists, so this is a silly thing, but that's fine. So what that actually does is it goes into my Google Container Registry. And so let me just search for that. And I have a lot of images, but the one we called it was Istio test. And so this is Google Container Registry. You can see all the images that I've pushed up with the latest tag 1.0. And a really cool thing about GCR is it can do vulnerability scanning. Obviously, this is like brand new, so there's none found. But if I actually click this, it will give me CVE's known vulnerabilities for our base images, which is really nice, automatically, right? Okay, so now the container is actually in the cloud. We can use it from our Kubernetes cluster. So if you've never seen GKE before, how many people are familiar with GKE? Few people, okay. So this is GKE. I already have one cluster created. Turns out, if you use gcping.com, you can find the fastest data center from your current location. So our Finland data center was slightly faster than Netherlands. So I'm using that. So I have one there, but if I want to create a new cluster, basically I can go through here and specify a bunch of stuff. So these are really nice templates. These are brand new. So you can like say, I want a GPU cluster, right? And it'll actually pre-configure a bunch of like stuff for GPUs. But let's just use standard cluster. We can create, this is like impossible to read because it's off the screen, but let me see. Make it a little smaller. A little smaller, don't really worry about it too much, but you can pick up a bunch of options. Zonal versus regional, number of VMs, auto-scaling, things like that, right? So all these kind of features that you can pick. The really important thing is it's just one click and you get to create a cluster, right? So let's just create that, and you can see it spinning up here, right? Like I said, I already have a cluster created, and we're going to use that one. Okay, cool. So let's now run our app on Kubernetes. So what does that really entail, right? So Kubernetes basically has two very important concepts, a deployment and a service. So a deployment is basically, here's my app, here's how many copies I want, and here's some environment variables for it, things like that. And then a service is, here's a static endpoint to route traffic to these dynamic number of copies of my app running. So the reason why we have separate concepts for services and deployments is because you can run multiple deployments and have a single service backing those multiple deployments. You can also have multiple services backing a single deployment. So you can basically mix and match based on tags for these things. Now, what does that really mean in practice? Zoom in. Okay, so what does it really mean in practice? Basically, most people run one deployment for one service. But we'll see what happens when we run more as well. So again, most people here in this audience probably know what I'm going to do next. I'm going to basically run a deployment. Let's see. Run standalone. And so what I'm going to do is create a namespace just for this demo, which doesn't really matter. And then I'm going to run that same Istio test container as a deployment, right? So I see this, and if I'm going, you can see here that we have one app running and one pod running. So a pod is basically a group of containers in Kubernetes. In this case, it's just a single container, and it's running already, which is great. Okay, so we have this container running, but how do we actually access it? And so that's what we need services for. Okay. I love make because it makes demos super easy. So what we're going to do here is just run kubectl expose, and we're going to say, target port 3000, port 80. So it'll take all traffic coming in from port 80 and then remap it to port 3000. And it's going to open up a type load balancer, which will give us a public IP address on the cloud. And so now what we can do is run the same command again. And you can see that we now have a service with a cluster IP. The external IP is still pending. It should take maybe like 5 more seconds. 5 more seconds. 5 more seconds. Oh man, okay. The moment I try something complicated, it's going to spin up, right? There it is, okay. So if I go here, it's going to look exactly the same as this, except now it's running in the cloud, right? So we have a public IP address. Anyone in this audience can go here and try it out, and it'll give you the current time. So all we've done right now is taken that one container and then run it on Kubernetes. So if you've ever been to a Kubernetes 101 talk, you are familiar with exactly what we went through, right? So here's where it's going to get interesting. So what I'm going to do now is run 3 copies of this app. So if we go back to the app, we can see that we're looking at environment variables to get the upstream URI and the service name, right? So what we're going to do is basically for the first app, we're going to leave it alone. It's going to go to world clock. For the second app, it's going to talk to that first app. And for the third app, it's going to talk to the second app. And then the third app is going to be exposed to the internet, right? So we should see basically all 3 apps communicating and then communicating back. So typical microservice synchronous pattern, right? So the way we're going to do that is use 3 different deployments and 3 different services. So if I go to this deployments.yaml, again, very important license. And then what we're going to do is basically run 3 deployments. And you can see here that our front end has the value middleware. And it gets this from the service. So we're using DNS-based service discovery, so we don't have to put in any IP addresses or anything like that. And then we're going to, in the middleware, we're going to actually have 2. We're going to have a middleware prod, and then we're going to have a middleware canary. And both of them are going to talk to the backend. And then finally, the backend is going to talk to worldclockapi.com. And in our services, you can see that we have 3. So front end, middleware, and backend. So the important thing to note here is that the middleware service, it's going to talk to both the canary and the prod deployments, because they both have this app middleware tag, right? So if we go back here into the tags, app middleware, right? So they have different version tags, but because they have the same app tag, it's going to, or label, sorry, it's going to route to both of them. Okay, so let's deploy this. Deploy stuff, the most wonderful names for things. So we've done a kubectl apply on both of these files, and we basically created these things. So if I run make get stuff, right, obviously. Oops. What it's going to do is it's going to spin up the backend, the front end, the middleware Canary, and the middleware prod, as well as our services. So backend, front end, and middleware. Now, I've already installed Istio into this cluster. Pretty soon we're going to have a fully managed version of Istio. You click a button, you get Istio. Basically, it's a big YAML file right now. You just go kubectl apply, and it'll just run it. And so what I've done is I've marked the default namespace with something called auto injection. So you might notice here that it says 2 out of 2 ready, right? This means that Istio actually added itself automatically to our container, or to our pod, without us having to do anything. So there's no Istio code or any like references to Istio anywhere in my code. But with this admission webhook, we've added Istio to our services transparently, right? So let's look at that. Okay, so everything is running. You might notice that there's no external IP for any of these services. So the first thing we gotta do is actually expose this container, right? And so we want to expose it using Ingress, an Istio Ingress. And so the reason why we want to do this is we want all traffic to always go through Istio. And we'll see why in a second. So here I have this external IP address. If I go to it, you'll see that absolutely nothing works. Okay, this is because we haven't set up Istio to actually send traffic to our service, right? So let's do that. So the first thing we want to do is basically set up that Ingress. Okay. So here is our Ingress gateway. So it's pretty straightforward. Basically, we're going to, from any host, we're going to send traffic to the to my gateway, right? So we're going to call it my gateway and send it to this Istio. So we're going to use the Istio Ingress gateway and take any traffic from that and send it to this my gateway. So what we're going to do is once we have this gateway called my gateway, we can create a virtual service for our front end. And we bind it to that gateway, and basically we forward all traffic to our front-end service. So this is basically just setting up that Ingress gateway and then the virtual service. That's basically the way you route things in Istio. So why would you want to do this? If you expose the service directly, right, if that service goes down, there's no way to detect that from a client side, right? So there's no load balancer or any sort of intelligence in front of that service. It's just a TCP load balancer. This gives you the capability of putting some sort of intelligent ingress in front of it, right? So let's actually run that. Cool. So now if we go back to here and hit refresh, you'll see everything working. Wait. Uh-oh. What is that? 404. Okay, so the front end is talking to the middleware is talking to the back end, and then World Clock API is giving us a 404. Clearly that is broken. If we go to World Clock API, just to make sure that the service isn't down, it works. So why is that happening? So this is the first security feature of Istio. By default, all egress traffic is blocked. Now, why would you want this? Let's say your developer forgets to uncomment out something, and it basically just dumps all your data to an unsecure S3 bucket. Whoops. Let's say that someone compromises your container and then starts running apt-get install their cryptocurrency miner. Whoops. By doing this, you're only allowing traffic to trusted third parties, and everything else is blocked, right? So let's open up a egress rule that allows us to talk to worldclockapi.com. Okay, so here is what the egress rule looks like. We call it a service entry. So basically, we're creating a third-party service that exists outside of our cluster. The host is worldclockapi.com, and I'm going to open up both HTTP and HTTPS. Cool. So let's run that. And now if I hit refresh, everything works. One thing you might notice is this is taking 1.133, this is taking 1.112, 1.082, right? So the time is going down. That's because our front end has to wait for the middleware to finish, the middleware has to wait for the backend to finish, right? So it's all encapsulation. So we can see that the vast majority of time is obviously going to this third party outside of our cluster, right? And everything else is only adding like 0.1 of a second. So now we have our egress working. One thing that you might notice here, if I hit refresh, check out this string right here, right? It's switching between prod and Canary. And so the reason why it's doing that is by default, Kubernetes load balancing is just round robin, right? So we have these two deployments and one service backing those two deployments. So it's just going to send to one and the other, and then one and the other. And there's no way for us to control that at all, right? So you could spin up a lot more prod, and then it'll just go to prod more often because there's more copies of it. But that's really not a good way to run a production service, right? You don't want your customer to randomly hit your testing services that are in your cluster. And you also don't want to have to hard code like different DNS names for your test stuff, right? Because then every single test path has to have different set of code and if-then statements and all this complicated stuff. Not good, especially if we have 1,000 microservices, right? So first of all, let's use Istio to lock down our traffic to always go to our production service. So to do that, what we need to do is set some routing rules. So we've seen our front-end virtual service before. Again, we're binding to that my gateway. What we're going to do is create virtual services, again, for our middleware and our backend, right? And so what we're doing here is we're setting everything to go to prod and setting everything to go to prod. What is prod, you ask? That's what we set in our destination rules. So virtual services are done on the client side, or so that like the virtual service, and then destination rules are done on the server side, if that makes sense, right? So this will basically say, you know, the subset name prod, anything with this version prod, right? These Kubernetes labels, and then what we're also going to do is enforce TLS with Istio mutual TLS. So these are two things. So one is just setting the subset, very simple. But this traffic policy is actually super, super important. So what this will do is it'll create, automatically create TLS certs. Istio will do that for you. And it'll only allow valid applications to talk to your application, right? So if someone hacks into your cluster, they actually won't be able to access your service without a valid cert, right? And you can actually lock this down even further. You can say only these two microservices can communicate, any other microservice cannot. And so this means that it kind of really reduces that blast area of effect if someone hacks into your cluster, right? No, it doesn't matter if they have access to the node. They actually have to get that cert, the correct cert to talk to that correct service. So we're going to set Istio mutual policies on all of them. In our middleware, we're going to, of course, define our two subsets, prod and Canary. And then again, for our backend, we're just going to set prod. So now we have these destination rules and our routing table. What we can do is deploy it. So remember, in our routing table, we're only sending traffic to prod for the middleware, even though in our destination rules, we're defining both sets, right? So let's apply those two files. And you can see I'm just using kubectl for everything. There's no special tooling or anything required for Istio. It's all done using CRDs, so nothing special you have to download if you don't want to. Okay, so now if we go back here, obviously, if we hit refresh a bunch, it only goes to our production service. So that's kind of a really powerful thing for Istio. We can set arbitrary routing rules without having to affect what's running in our cluster, right? We're actually setting the routing itself. And because this is done at a per container level, and because we have certificates for everything, we can't get man-in-the-middle attacks. All these kind of stuff is all taken care of for us, which is really nice. Okay, so that was fun. We basically ran our routing rules pretty straightforward. But one thing that we want to do is actually get traffic to our Canary service, right? And so right now, no traffic is possible to go there. But what we're going to do is send some special traffic to our Canary service. And so the way we can do this is we can actually, wait, I got ahead of myself. Hold on, one second. Let me go back in time. Pretend I didn't say that. So I wrote really bad code, and I have a little function called create issues. It's a fun function. What it does is it looks at a header called fail, and if that header is 50 or like just under this random number, it just throws a 500, right? So flaky errors. So what I'm going to do is go here and paste it in here. Cool, everything works fine, right? But now I'm going to set that header called fail, and I'm going to put in a value of 0.7. So this is Postman, or 0.3, sure, why not? So 30% of the time it should fail. It's not really 30%, I do my math wrong, but whatever. So you can see here now it's throwing a 500, but sometimes it doesn't, sometimes it completely crashes. Who knows, it's flaky, right? So the first thing we want to do is fix that flakiness. So this is something that happens in a lot of applications where you had to add retry logic to your apps, right? So if it fails, then try again, try again, try again. And you had to add this to every single app, and if you have 1,000 microservices, it gets really annoying. So with Istio, we can actually set that at the service level automatically. So what we're going to do is in our virtual service, we can just set retries attempts 3 per try timeout 2. And you can set a lot more stuff like circuit breaking and a lot of like complicated stuff here. But all I have to do is put this in. So let's do retry. Oh, okay. And so now we can go back to our code into Postman and hit send. And you can see that 3 retries was enough to overcome our great code that we wrote that runs 500s, right? But if I put this value higher, something like 90% failure, right? It's not enough time, right? So it won't fix your code for you, but it'll make your life a lot easier if you have flaky services, right? So how would you detect if your service is flaky, right? Obviously, here it's kind of obvious because it just crashes. But one thing Istio does, how many people were in Tom's talk about Prometheus? Few people. Okay. So one thing that Istio does is it automatically creates Prometheus metrics for you. It automatically creates distributed tracing for you. So you can actually get a bunch of metrics from your application without writing a single line of code. So what we're going to do is actually look at that stuff. So, awesome. Okay. So first, let's look at whatever is on port 3000. I forget which one it is. Grafana. Okay. So Grafana is a front end for Prometheus. Wait for it to load. All right, there we go. And so I should get a dashboard for us automatically. So Istio Galley dashboard, sure, why not? So you can see here some interesting stuff. That's not really important. What I want is my own apps. Okay, cool. So we get stuff like non-500s, right? So the moment I turned on that bad header, you can see that my success rate dropped to like 77%, right? You can see all these kind of which ones are secure with MTLS, the response codes, the response size, the latency, all this stuff automatically without adding a single line of code to our application. So the really nice thing is for your operations folks, you get this full end-to-end metrics without putting a burden on your developers. So of course, these are all network metrics, but it's better than nothing, right? Again, 0 effort to get all of these metrics. Okay, cool. So another thing you can do is, let's go back to our makefile real fast. So is distributed tracing, right? And I forget which port, so I'm just going to look at this thing. 16686. What a good number. All right. So what we're going to do is run Jaeger, which is one of the available distributed tracing software out there, built by Uber, I believe. And so here, what we can do is find traces. Oh, let's select service. Let's look at backend. Find traces. And if I click this one, you can basically see our Ingress gateway talk to the front end, talk to the middleware, talk to the back end. And the back end talk to worldclock.api.com, right? So you can actually tie in all these services and see which one is taking a lot of time where. And so, again, completely automatic. The one thing that you have to do is forward the trace headers. And so if we go to our code, you can see here I'm basically just forwarding these B3 headers along the way, right? If you don't want to forward these headers, come to my talk tomorrow where I go a much more advanced talk on Istio and OpenCensus. But for right now, you just have to forward these headers along. These headers are created for you automatically, so you don't have to really care what's in them. Istio creates them at the Ingress gateway. Just forward them for all of your HTTP requests. So once you do this, you get that distributed tracing. And you can see, obviously, in our app that the backend takes the vast majority of time, and then our middleware and front end just add very little at the very beginning and end to call that stuff, right? So basically, you can see where in your application, in your distributed application, right, you might have hundreds of these services. What is taking the most time? And it's like a typical waterfall chart that makes it a lot easier. Okay, now last thing. Again, if you go back here, always going to prod, right? How do we change that? We want to test. We want to do something called production testing or Canary testing in production, right? So typically, you would run your microservices. You have too many to run locally, right? So with a monolith, you could probably spin it up on a test cluster, and you know everything runs the way it's supposed to because it's a compiled something, right? It's a big blob that comes out. If you have 100 microservices, it's really hard to spin up the exact stack and then replace your code because everyone is changing their stuff constantly, right? So you kind of have to test in production, but you don't want your customers to, hit your broken code, right? So with Istio, you can actually dynamically route traffic to different services based on headers, and you can do like traffic duplication to different services and all this kind of cool stuff, right? So what we're going to do is our final routing table. We're going to keep that retries, right? But what we're going to do is for our middleware service, we're going to look at a header called xdev_user, and whenever we see the string super secret, we're going to send it to our Canary service instead of prod. So here, I can go in here and put a new key called xdev_user. And again, you can put any arbitrary thing. You can use regex, so you can say all iPhone users go to this specific iPhone version of our service, whatever, right? And put in super secret, and hit send. Did I spell it right? Let's see. Oh, you know what? Okay, so obviously, if I send it and I don't actually write the config to actually respond to that, nothing's going to happen. So let's actually do that and make Canary. Okay, cool. So now, if I hit send, we can see that it went to Canary, right? And I didn't have to change any of my code. I didn't have to change any of my services or anything like that. I just tell Istio to route it to a different version of my already running code if it sees this header, right? So in my code, I have no idea what I'm looking for. It's just done at the Istio level instead. So it makes it a lot easier from the developer side because I just write my code and I use the infrastructure itself to send the traffic where I need it to be sent, right? So I don't have to worry about a lot of if-then statements or flags and things like that. I can instead push that to a lower level and abstract away, which is really nice. So that's kind of the end. So you can see right now that if we go back to our slides, with Istio, with Kubernetes, we kind of were able to run these containers on the cloud. Each one was 3 different deployments. And then with Istio, we were able to configure them, secure them, route them to the right place, and really ensure and monitor and manage them, again, without doing anything specific for Istio, right? It just kind of adds all these capabilities for free out of the box, which is really nice. So this is kind of the beginner intro talk. If you're interested in more Istio, and especially on the monitoring side, I'm going to go much more deeper, much more advanced tomorrow. And then also tomorrow's talk on Knative, which is a level on top of Istio and Kubernetes that gives you like serverless capabilities by Eor. So I'd recommend going to those two if you want a more advanced talk. If you want all the code to this, it's right there on, if you go to my name.com/istio101, it'll go to the video recording, and then a link to the GitHub repository. If you want to learn more about GKE, you can go to g.co.gke or istio.io for Istio. Tweet at me, whatever you want to call it, at Sandeep Dinesh. And then my GitHub is the Sandlord. Again, all this code is open source. And it's the same repository that I'll be working on tomorrow, but looking much more deeper into distributed metrics and tracing. So with that, I think we have time for some questions. Thank you all so much.